Hello, everybody. Good morning, good morning, good morning. Welcome. We are going to go through some slides today. The slides I posted about 15 minutes ago in the classroom. Hopefully, you have them open and you're ready to look at them as we go through. Just in case I haven't mentioned to you guys, sometimes I get lost as to what period and what day it is nowadays. Um, Third cycle is what it is. Third cycle, the grades are up there, and they are going to be put in today, I believe, by Mr. Tejada. So I've been telling you all along for many, many, many weeks. If you do something late, that's okay, but you have to private message me and tell me you did it. I don't know you did something late unless you private message me. So I'm assuming by now you all got that message and you are looking through the grades and you are making sure that they match what you have in your head. And they are what they are. Whatever you do from this point on, like I mentioned from the last slideshow, when we talked about pesticides, everything from pesticides on will be fourth cycle. All right. Big thing I'll talk about sort of at the end of these slides is that you have give a quiz next time we meet. So I'll go over that at the end of the slides and tell you which things we have to concentrate on and which dates you have to concentrate on. All right. So I'm going to get right into the slides today because I don't have too much to say. Make sure you're signing the daily attendance and all that blah, blah, blah. It's probably getting boring hearing the same things. All right. Today, last time, or actually before spring break, we have been talking about agriculture. We've been talking about agriculture. We've been talking about how farmers try to maximize their yields. So they did things like crop rotations, right? And we talked about the Green Revolution, and we talked about how everyone, farmers got to a point where they could do everything really efficiently, naturally, and then they couldn't break that ceiling. And that's when GMOs and science came in, and genetic engineering we talked about. And then we talked about the importance of irrigation and water and the land and the soil nutrients. And then we talked about pesticides last time we met, right? So, looking at the slides now, slide one says we are learning about integrated pest management. So, we know pesticides aren't great. And when we think of pesticides, we think of poisons being sprayed by planes all over the crops and poisoning everything, and that's not wrong. But there is this thing called integrated pest management, and it's a series of events that have to happen before you get to that extreme level. They don't just let people dump pesticides just for fun. There is a process, and the process is called integrated pest management. So it's a way to monitor and decide and take the time to make a rational decision. Right? So that's what we're learning about today. Slide two is just the agenda. Look at it at your leisure. Slide three, as usual, is a review from the last thing we did, which was pesticides. So look at that at your leisure. And slide four is the objective, as usual. And the objective says that by the end of this lesson, you're going to be able to explain integrated pest management. Yay. All right. Slide five. Here's where we start. So, what is it? Integrated pest management. We're going to be calling that IPM from now on instead of using all those words. So we can abbreviate it IPM, Integrated Pest Management. So IPM isn't a single pest control method. It's not a solving thing. It's more of a process. Okay, it's a process that evaluates and monitors, and then there's decisions and there's controls. All right, we know when there's a pest that we need to control it somehow. We've talked about that when we dealt with pesticides. So there's 4 steps to this IPM process. The 4 steps are as stated on the slide. The first thing you have to do is set action thresholds. The second thing is prevention. The third thing is monitor and identify pests. And then the 4th step is control. So the next 4 slides go over these 4 steps in detail. So these are the 4 steps of IPM. Probably need to know that for a quiz or a test. All right. Now, step 1 is to set action thresholds. What does that mean? If you don't know what a threshold is a point where if you go beyond something, some action takes place. So you can have a patience threshold, right? Like I have a lot of patience right now, but my patience threshold is right here. And if you're pushing that patience and pushing that patience and pushing it, you can pass my patient threshold, and I will not be patient anymore, right? So it's usually a point, right? So an IPM, setting an action threshold for IPM, is a point at which the pest population or environmental conditions indicate that pest control action must be taken. All right. A farmer goes outside and looks at his crops, and he's looking around and he sees a caterpillar, and a caterpillar happens to be dangerous to the crop he's growing, could be a pest. Farmer freaks out. Oh my God, I got caterpillars in my crops. I got caterpillars in my crops. Oh no. Dude, you saw one or two caterpillars. Okay. So, in the past, maybe they would have said, oh no, let's spray the fields, because they didn't know the damage it did. Now, whoa, whoa, whoa. Let's set a threshold here, right? So the threshold for every farm, for every crop, for every pest is different. All right. And that's what it says here. Citing a single pest does not always mean control is needed. And the level at which pests will become an economic threat is critical to guide future pest control decisions. So what that means is this action threshold. They set the action threshold according to a couple variables. They will look at the pests, right, and they will obviously see how many pests do we see, how many caterpillars are really in this field, and that's so we're not going to take any action until we see 2,000 caterpillars, let's say, right? This guy only saw one, so there would have to be some sort of observation, some sort of count, some sort of hunt for these things, right? You would walk up and down your fields and you would see if you can count up to 2,000, and then you're past that threshold, right? So there's a numbers threshold on how many pests, and there's also an economic level. When it becomes an economic threat, then that's a problem. We already talked about how farmers typically lose some part of their crops to pests. And I think the number in the 40s was around 7% of their crops to pests. And in nowadays, I think they said it was up to 13% of the lost crops, right? So when you lose a certain percentage of your crops, you're losing money, obviously, you or the industry or whatever. So they set an economic threat. Like if you lose up to 20% of your crops, then you've passed the threshold. So they use those two variables. They use that, okay, let's set an economic threshold, meaning if you're losing more than 15% of your crops, you've passed that threshold and action needs to be taken. Or if we can identify that there's more than 2,000 caterpillars in your field, you've passed the threshold. All right, so that's what it is. So the first thing that has to happen is you have to set an action threshold. And every action threshold is different. Every farm is different depending on the size of it, depending on what they're growing, depending on where it is, depending on how much that stuff sells for. So every farm or every industry or every large crop has its own action threshold. Also, how susceptible is it to pests? Some, like we talked about, aren't that susceptible to pests. Avocados and things like that don't have too many pests, where apples do. So there's a lot of variables that go into it, and there's an agency that would help set action thresholds for crops. All right, step 2 is prevention, right? Being proactive. So at the first line of pest control, IPM programs work to manage crops, lawns, indoor spaces to prevent pests from becoming a threat. All right. So it's prevention. So, if you are someone who's really into landscaping, I don't care. I just cut my grass. But some people really cut their grass and they're very proud of their nice lawn and all this stuff. What they would do is when they cut their grass, I cut my grass. I don't care if something starts to grow and weeds and stuff like that. I'll go buy some spray and I'll spray it or not, whatever. I don't really even care. But if somebody cares about their lawn and cares about how it looks perfect, like a golf course, for instance, they don't just sit there and wait for weeds and problems and pests to come up. They prevent them. They have proactive preventative measures where they may have some control as far as putting natural things down on the lawns, cutting the lawns, keeping the lawns at a certain distance, the things that surround the lawn or the golf course, make sure that there's no pests in the woods and stuff like that. So they do the same thing with crops. They try to prevent pests proactively. And what they can do to do that is they can use different cultural methods. They can rotate crops. So when you rotate crops, if you keep a crop in the same spot, pests kind of know where it is and they want a snack, they're going to go to it. But if you're moving crops around, if you have enough land like that and you're doing that, the pests have a harder time finding it. So it's sort of hiding them, year to year, in a sense. You can select pest resistant varieties. So there are seeds, there are crops that are genetically engineered to be pest resistant. Right now, you can, I'm sure this method is more expensive to purchase the seeds and the crops that are pest resistant, but it might be worth it if you're in an area where you get a lot of pests, right? Um, so these control methods can be very effective and they can be cost efficient and they present no risk to humans, right? There's like no risk to people because you're preventing, right? It could also mean I'm going to grow this farm right here and I'm going to grow this crop, but I'm surrounded by woods, and there could be a lot of insects or a lot of animals that come from those woods. So you can put up a fence, right? That's a way to prevent. So there's a lot of different ways. Just think proactive, how are we going to prevent this stuff, right? So let's just try to keep them out. So let's set an action threshold. Let's try to prevent them and be very as proactive as we can to not have them come in. Slide 8. Slide 8 is step 3, monitor and identify pests. So you can't just sit back and set an action threshold and throw down, put a fence up and say, okay, I'm good, and then go to sleep for 3 months and expect to have nice crops. You have to monitor your agriculture. You have to monitor your crops at all times. So when you do that, now it's the farmer again. The farmer comes outside, sees a couple caterpillars and says, "Uh-oh, okay." So he's going to go and do, hopefully he's done these preventative measures and stuff like that. He's going to go out and he's going to monitor. He's going to walk up and down his crops. He's going to look for more signs of caterpillar action, caterpillar activity, right? He's going to do that stuff. He's going to monitor and also identify pests. So what it says here in the slide is not all insects, weeds, and other living things require control. All right. Many organisms are innocuous. That means that they're not dangerous. They're not detrimental. And some are even beneficial. So sometimes if you see, some insects like ladybugs might eat other insects that could be. So it would be a good thing to have ladybugs in your crops because they eat other pests and they're not pests. They don't hurt the crops. So there's things like that. IPM programs work to monitor for pests and identify them accurately so the appropriate control decisions can be made. All right, with the action threshold. So first, you sort of, I look at this as switched. I identify what is actually a pest to my crops, to the things that I'm growing, and then I monitor carefully to make sure that I'm not saying, the ladybugs eat too. So they're, ladybugs will feed on the leaves and stuff, but they won't be detrimental to the plants. So you have to really identify which things are pests and then monitor them closely. That's what they're saying here. Slide 9 is control. So this is step 4. All right. So once you've monitored, you've identified, the action thresholds are broken or passed, where you realize that, okay, even though I have had preventative methods, all this stuff, you still have broken the thresholds and you need control. All right. Because just being proactive, those proactive measures, those fences or those crop rotations, they weren't effective enough. Right. So you tried your best. Boom, action thresholds are broken. We're losing a lot of our crops, and I see 10,000 caterpillars. We got a problem, right? So that's when control comes in. That's when we move to step 4. Now, IPM programs evaluate the proper control method for effectiveness and risk. So, depending on what pest it is, depending on what's going on, depending on where it is and how much of it is, they will go through and in order to control, again, they don't just pull a plane out and start dumping chemicals, poisonous chemicals all over the place. They first go for the effective, less risky pest controls. All right. So one of them is, well, the main one is called biological control. So you can try to biologically control this. We saw this when we did the bullfrogs a couple of months ago, and we said there was a bullfrog population and it was exploding, and we were trying to control the bullfrogs. What we did was we introduced largemouth bass to the pond, the fish, and the fish fed on the tadpoles of the bullfrogs, and they controlled the population. That was a biological control. It was a natural, let nature take its course. Let's introduce something that will kill this pest, and let's let nature take its course, right? So that's what they're talking about here. They're talking about biological control to control the pests. So they'll bring in natural predators, right? Say you have caterpillars and they're the pests, and then you have this whatever, this bird that eats caterpillars, right? You can bring this bird into your area. You can actually buy some of these birds and bring them into your area, and hopefully they stay there. And if they have food and those caterpillars, they're gonna stay there, so they would naturally control that population, that pest, right? Pathogens, parasites. So if you know, not you, but if science knows about the parasites of a pest, like, okay, I know that this pest is susceptible to this type of parasite, they can actually introduce the parasite to the pest population, and the parasite would spread through the pest population and kill the pest, right? So they do this biological control, and it's pretty cool. They'll also, the next step, if that biological control isn't working, or if it isn't feasible, if it's a pest that doesn't have a natural predator, then they do a highly targeted chemical spray. And what they'll use first, they're not using the poison pesticides yet. What they'll do is they'll try to disrupt the mating, the reproduction of the pest. So they will use pheromones. They'll use targeted chemicals such as pheromones. Now, pheromones are natural chemicals that animals secrete when it's mating time. It's to attract a mate, so they'll secrete these pheromones. The male or the female will smell these pheromones. There's an attraction. It knows that it's mating. Animals know that it's mating time, and then that stuff happens. So if chemicals can target the pheromones, or you can use different pheromones to disrupt the mating cycle, then those pheromones aren't an attractive type of pheromone. They could be a pheromone used for aggressiveness or something. So these pests would actually stay away from each other. They wouldn't mate, they wouldn't reproduce. So that's an interesting way to do it. And then there's also a mechanical control, right? So if it's a larger pest, you can trap it, right? If it's a plant, you can pull the weeds, right? You can pull the weeds out yourself if it's the weeds of the pests. So again, there's biological control, there's pheromone, like natural chemical control to disrupt mating, and then there's mechanical control, such as trapping and actually hand weeding and stuff like that, which a lot of people will do. If there's a lot of farms will do weeding. They'll actually hire people to walk around the crops and make sure that weeds aren't growing and to pick the weeds and stuff like that. All right, slide 10 is what happens when none of that works. See, so you can see that this is a really long process. This isn't like, okay, let's just go out and make food and poison people. So with further monitoring, so now you have to monitor that. You have to identify how many are being killed, and it takes a while to do this. If they're not working, then additional pest control methods would be employed, right? The first thing that would be employed is called targeted spraying. So if you see that the most pets happen to be in the southwest corner of your field, if there's an area, if they're not just spread everywhere, if there's an area of the field, oh, this 25% of the crops have all the pests on them, or 90% of the pests, you can target spray. So you can either actually use hand tanks and have someone go around and spray them if it's a small area, or you can use a tractor like you see in the picture in slide 10. And they can go across just that area where they've seen pests and they can spray. Finally, in that bottom picture you see on the slide there, if all else fails, as a last resort, you've done everything, you've gone through all these steps, you've tried all these natural methods, you've target sprayed, nothing's going, it's just not stopping. Boom. Then you do something called broadcast spraying. And that's what I refer to as crop dusting. That is when you get a plane, you fill it with whatever pesticide's going to work, you cruise over the fields, and boom, open the tanks. And you see in that picture, you see that big dusting, as they call it, the mist of pesticides falls on the entire crop and usually takes care of the situation. Right? But we already know what that leads to because we talked about that last time. So those are the 4 steps of IPM. And you do need to know them, not word for word from the slides, but you need to be able to explain them a little bit like I did. Then we get into slide 11, which is guided practice. But slide 12, so skip over slide 11 for a second. I think that's sort of out of place. Slide 12 is talking about organic food. So we mentioned organic food a couple of times in the last few lessons. What does it mean to be organic food, right? So there is the FDA has a certification, or the USDA has a certification, is certified organic, right? So when you go to the store and you buy organic food, you should see a little seal on it that says USDA certified organic. Um, and if you don't, it's probably not super true, and we'll see that in a minute. So what does it mean to be truly organic? For something to be truly organic, you could have no human sludge fertilizer used in cultivation of the plants or the feed of the animals. Yes, there is human sewage sludge that is used as fertilizer on some farms, and yes, that's disgusting. But if no human sewage sludge fertilizer was used, that's step one. You need to avoid all synthetic chemical inputs. All synthetic chemical inputs. There's a huge list that you're not allowed, prohibited substances, in order to be considered organic. Genetically modified organisms, antibiotics, pesticides, food additives. There's a bunch of different things that you can't use or have on or in your food for it to be considered organic. The next step is you need to use farmland that has been free from all of these synthetic prohibited chemicals for at least 3 years. So you can't buy a farm and start saying, I'm going to be organic. Or you can't be farming 1 year and then the next year say, I'm going to go all organic. Because if you've been using pesticides on that land, you have to wait at least 3 years to use the land for organic farming. You have to keep detailed and written production sales records, and you have to maintain strict physical separation of organic products from non-certified products. So if you do become organic certified and you're just growing one crop that's organic, but you have other crops on your farm that are not organic, you have to make sure that you can't cross over anything. You can't use the same equipment. You can't use the same processing plant. You can't use the same storage facilities. It all has to be separate. And then finally, you have to undergo periodic on-site inspections. The USDA will come and they will check your farm. They will not tell you they're coming, but they will check and make sure that all these things are being taken care of. Slide 13 shows you that there are different levels of organic. So you see the first two levels are USDA organic. That's the certification that met all of those things. All right. If it says, let me bring this up a little higher. Full screen because I can't see everything. Full screen, full screen, full screen. Here we so slow. Come on. Okay, so 100% organic. The use of USDA organic seal is optional. Okay, they don't have to use that seal, but they will. If they went through all that process to become organic, they will most likely use that seal. When it says 100% organic, that means everything about it is. If it just says organic and it has the seal, it means that 95% or more organic ingredients are in that food. All right. Those are the two levels that can use the seal if they want, and they always do, because why wouldn't they if they're saying they're organic? Because there are two other levels. There's something that says made with organic ingredients, right? And that means that at least 70% of the organic ingredients are in that food. Now, the problem is a lot of companies won't write made with organic ingredients. They'll just say organic, organically made, organic. So you think you're getting something that's in the 95 or 100 percentile, and you're really only getting something that's 70. So if that matters to you, then that's a problem. And that's why you can't get a seal if it's 70, and you can't get a seal for less than 70. All right. But companies can label their food and their stuff as organic, even without the seal. And if you aren't wise to that, you think if you're trying to eat healthy and you're trying to buy organic, you're going to be buying this stuff not knowing that it could have 10% organic ingredients in it. So you have to be careful of the wording, and you always look for that seal if you wanted organic food. And again, some people doesn't matter. Some people, and what we said was, when you're buying this organic stuff, yes, it's healthier, it's more expensive, but again, we're being exposed to pesticides in so many other ways that it sucks that it defeats the purpose sometimes. It's very helpful, but it's not the cure-all. All right, slide 14 says independent practice. Now, slide 15 and slide 16, it's sort of this interactive thing, and this is optional, which means that I'm not grading it. You don't have to hand it in. The reason why I'm not giving you a written assignment for today is because the next time we meet, we are having a quiz. So I'll be going live for a few minutes and then posting a quiz. So I want to not give you something else to do. In the materials, there is a little review that asks you about IPM. So you can look back to the materials there, like we always have. We have the daily attendance, we have the slides, and then there's another sort of exit ticket, right? So when we're looking at the quiz, we are looking at about, I can see how many questions there are if you give me a second. All right, let's look here. I'm going to go full screen so I can see it easier. Just give me a second and I will find out how many questions. Oh, wait, I can find it here. Here we go. Much easier. Here we go. Let's open this up. And this will give me a good way to actually look at it and talk about it for a second. All right, so quiz 1. So the date is important. From 3/27, from March 27th, that is the start of this group of slides that'll be on the quiz. So from 3/27 to today is going to be on the quiz. I think right before 3/27 was our unit test. So you go back to the unit test on our classroom scroll and then go to the next set of materials. It will be lesson 2. We skipped lesson 1 for agriculture. So lesson 2, lesson 3, lesson 4, lesson 5, lesson 6, and today was lesson 7. So there's 7 sets of slides for the quiz. All right, I am looking at the quiz now. You wish you were. And the question was, how many questions are on the quiz? I am looking right now at 8. There are 8 questions on the quiz. A couple of them are A and B. So, it's 1 AB. And then it's 2, 3, 4, 5, 6, 7, and then 8 A, B, C, and D. All right. So, it's about 15 questions altogether. Not too bad. There is a graph that you have to look at and interpret, which you guys are really easy. It's really easy for you guys to do that. So that's it's kind of a gimme. Yep, you are going all the way back to the beginning of the agriculture quiz. All right. What else? So that will be no problem, Nick. That will be the next time we meet. So again, I'll go live for a few minutes just in case anyone has any questions, and then I'll post the quiz. As we've been doing, I would love for you to do that quiz. I will most likely grade that quiz the night of or the next night. So you have, the day and a little bit of the next day to get it done. Once I grade that quiz and the grades are in, if you didn't finish it yet for any reason, and you finish it late, you have to private message me and you have to let me know that you've turned it in late. And that's not a problem. It's no big deal. I'm not going to take points off for it being late, but you just need to let me know so I can go grade it. All right. I think that's about it for now. Like I said, there's nothing due today because you should be utilizing this time to study. And I believe that we meet again on Monday, if I'm not mistaken. So that is it. I have to go get ready for our next class. If you have any issues whatsoever, please private message me. I hope you guys are staying safe and calm and smart and strong and all that fun stuff. And hopefully I get to see you guys again for a few weeks before it's the end of your time at Technology High School. All right, I'll talk to you soon.